Alright, the next bunch of problems is about constructions. So this one is for an angle bisector. It wants to know which one illustrates the correct construction. So this is card 22, construct a bisector of a given angle, and you could see it needs to look like that. So the only one that looks like that is choice 3. Okay? The diagram below shows the construction of the bisector of an angle. So this is the same thing we just talked about. Which statement is not true? Okay? So the measure of angle EBF, that's this smaller angle, is equal to 1/2 of the measure of the large angle. That's true. The measure of DBF, which is this smaller angle, is equal to the 1/2 the measure of the large angle. That's true. Right, because each one of these is 1/2 of the big angle. So 1 and 2 are true. Number 3 is EBF is equal to ABC. EBF is obviously not equal to ABC. Okay, this small angle is not equal to this big angle. So it's choice 3. Based on the construction below, which statement must be true? This is probably the same type of question. Alright. It has ABD, which is this small one, is equal to 1/2 of CBD. CBD. That one's not true. Okay, so which... Oh, it's asking me which one is true. So 1 is not true. 2 says ABD equal to CBD. That one is true. Okay, this little one is equal to this one, right? That's why it's called an angle bisector. Alright, it looks like they really like to ask a lot about this angle bisector stuff. So you have a straight edge and compass were used to create the construction below. Arc EF was drawn from point B, and arcs with equal radii were drawn from E and F. Which statement is false? ABD equals DBC. That's true. This little angle ABD equals this little angle DBC. 1/2 of ABC, so half of the big one is equal to ABD. That's true, is equal to the small one. 2 times DBC is equal to ABC. That's true. And 2 times ABC is equal to CBD. That's obviously not true. As shown in the diagram below of triangle ABC, a compass is used to find points D and D, equidistant from point A. So here's our first arc, right? They just didn't continue the whole thing, but that they don't have to. And they're equidistant from point A. Next, the compass is used to find point F, which is equidistant from points D and E. So then it went to D and it made an arc, and E and it made an arc. What it did was it did the construct of angle bisector. It did this exact, it did this, all right, to this angle right here. See, the only thing they didn't do was continue this, and they don't have to, all right, but they could have. So they bisected that angle. So which statement must be true? AF bisects side BC. No, that's not true. AF bisects angle BAC. That's it right there. It's an angle bisector. Using a compass and straight edge, construct the angle bisector of triangle ABC shown below. Leave all construction marks. So this is one of the easiest ones. I need to actually take this page out to do this one. Okay, so we put our compass here and we go somewhere in the middle-ish of the angle. That's fine. Then we just go from this point and we make an arc in the angle, and we go from this point and we make the same arc, and then where they cross we draw a point from the vertex through that point. So that's how we do this problem. Alright, so that's the end of that one. Now we do another one of those types of problems. Okay? And it's the same deal. Alright, we go right through the intersection. Just like that. Okay? And the next problem is another one. So it really likes to ask you guys this problem. You better know how to do this one. I mean, you should be happy because this is one of the easiest constructions that there are, or that there is. There we go. This time they tried to trick you a little bit because they give you a triangle, but they just want you to bisect an angle, so it doesn't matter if they give you a triangle, you just bisect whatever angle they're telling you to do. It says angle CBA, so that's this angle over here. So I just do the same thing. I pretend that other side wasn't even there. There's my first arc. This is kind of like that problem that we did a little bit earlier. Right, that's the answer to that one. Okay, and then we have even another one where we just do the same thing. Okay, and there you have it. Now, we move on to the next. We're still on constructions, but now they're talking about a different one. This one is the diagram below shows the construction of the perpendicular bisector, right? So it bisects this segment into two congruent pieces perpendicularly, so that's a 90-degree angle. Which statement is not true? AC is equal to CB. Well, that's true because this bisects it. CB is 1/2 of AB. This is 1/2 of the whole thing. That's true. AC equals 2 times AB. That's not true. AC is not equal to twice the length of the long one. All right. If you had that in reverse, that would be true. AB is equal to 2AC, but not AC equal to 2AB. That's wrong. One step in a construction uses the endpoints of AB to create arcs with the same radii. The arcs intersect above and below the segment. What is the relationship of AB and the line connecting the points of intersection of these arcs? It's perpendicular. This is a perpendicular bisector, right? What they're saying is that A, B, and you have two circles, two arcs with equal radii. Here's one. Here's two. Oops, which one did I go by? Let me double check that. I went by the close one. So that's what you have, right? Perpendicular, this congruent to this. So that's what this says. The arcs intersect above and below the segment, see? What is the relationship of AB and the line connecting the points of intersection? What is the relationship of these two lines? They're perpendicular. 109. Which diagram shows the construction of the perpendicular bisector of AB? Well, it's number 1. The other ones are not perpendicular bisector. Okay, perpendicular bisector is number 1 right here. Right? This is card 23. Right? So it's right there. Line segment AB is shown in the diagram below. Did you see what they did? Let me think actually. What did they do here? Okay. Which two sets of construction marks labeled 1, 2, 3, and 4 are part of the construction of the perpendicular bisector of line segment AB? Well, let's take a look. We don't have anything on the ends of the point, on the ends of the line. All we have is these two things up here, right? They just didn't make the whole half of a circle. They just made a little arc here and a little one here. And you can do that. You can see what would happen if we connected those. It would be this exact picture. So you need 1 and you need 3. That's choice 2. Okay, and the last one. On the diagram of triangle ABC shown below, use a compass and straight edge to construct the perpendicular bisector of AC. So we're just looking at it this way. All we care about is AC. Go a little more than halfway. Do the same thing from the other side. That's it. Okay? We just perpendicularly bisected this line segment AC. Okay? Now we're on a different type of construction. We're talking about parallel lines here. The diagram below illustrates the construction of PS parallel to RQ through point P. Okay, that's card 24 where you're constructing parallel lines. Okay, you see how it's the same thing? Alright, remember that these two angles are corresponding angles. That's why these lines are parallel, because when corresponding angles are the same, which we know they are, okay, because we did the construction so that it was the same angle, that means these two lines are parallel. So which statement justifies this construction? The measure of angle 1 is equal to the measure of angle 2. Alright, because those two angles are the same, those two lines must be parallel, right? If you just think about it, if one of those angles was different, those lines would be, they wouldn't be parallel, they would be turned, okay? So since those angles are the same, those lines are exactly parallel. Alright? So it's answer 1. Which geometric principle is used to justify the construction below? Okay, when two lines are intersected by a transversal, remember this line is the transversal, and the corresponding angles are congruent, these are corresponding angles, okay? When they're congruent, that proves that those two lines are parallel, so that's choice 4. That's straight out of the construction. Now we're on a different type of construction, I believe. Or maybe not. The diagram below shows a construction of a line through point P perpendicular to line M. That is construction number 26. That's perpendicular through a line when the point is not on the given line. See? And it could be done this way or it could be done this way. It doesn't matter. Do you see how these two arcs cross up here? Well, they could cross above the point or they could cross below. It doesn't make a difference. Okay? Which statement is demonstrated by this construction? If a line is parallel to a line that is perpendicular to a third line, then the line is also perpendicular to the third line. No, there's only two lines here. There's not even a third line. The set of points equidistant from the endpoints of a line segment is the perpendicular bisector of the segment. Two lines are perpendicular if they are equidistant from a given point. Two lines are perpendicular if they intersect to form a vertical line. Alright, so the only one that this could be is choice 2. The set of points equidistant from the endpoints of a line segment is the perpendicular bisector of the segment. Okay? So these points are all equidistant from the endpoints of the line segment, from here and from here.
Okay, they're all equidistant, right? This is the same distance as this, and this is the same distance as this, and this is the same distance as this. All the points along this line are the same distance from this point as they are from this point. Okay? So it's choice, I think I just said 2. Okay? Let's look at the next one. Using a compass and a straight edge, construct a line perpendicular to AB through P. So this is this guy, 25. Construct a line perpendicular to a given line through a given point when the point is on the line. Alright, so it should look like this. So first we just take our compass and we make an arc like that. And then we go either below, we can go down here and make 2 crossing arcs, or we can do it above it. I'm going to do it above it, which is how it's done here. But you could also do it below it. Alright, but I'm just going to do it the way we usually do it. Okay? There you go. And, you know, this should be only one. You should fix that if you're on the Regents exam. Make sure it's 1 arc. Okay. Like that. You just fudge it a little bit. Diagram below shows a construction of line AB through point P parallel to CD. So this goes back to the parallel one. Which theorem justifies this method of construction? It's probably the corresponding angles theorem. Which one says correspond? Here it is, number 2. If 2 lines in a plane are cut by a transversal to form congruent corresponding angles, that's what these are, corresponding angles, then the lines are parallel. So that's what it is. Choice 2. Using a compass and a straight edge, construct a line that passes through point P and is perpendicular to line M. Okay. So let's do this one, which is like 26, right? We can do it like this. Okay. We can also do it with these crossing points down here below. It's up to you. It doesn't matter. So the important thing is to go on point P and to cross that line twice, like this. Bink. Now we can make, we're going to go from each one of these points, and we got to make 2 little arcs that cross, like this. Now we can do it above the point, or we can do it below, down here. And since point P, this will be in the way if I do it above, I'm going to do it below. So I'll just put my compass here, make 1 crossing thing, and I'll put my compass on that intersection, and I'll make another cross. So this time, you see how it's a little different? This time I did these crossing things below the line, and that doesn't make a difference. You can do it above or below. Okay? So that's that one. Now we're going to talk about equilateral triangle constructions. Which diagram shows the construction of an equilateral triangle? There's a lot of ways to do it, but this is the way they're talking about, right? They just didn't continue the arcs, okay? But you see this, it matters where it crosses the line, okay? So we have this one, and we have those 2 crossing up top. So it looks like it's that one, but let's just take a quick look. Yeah, the other choices aren't even close. So that's it, choice 1. 119. Again, it's going to be choice 1. You see, the other ones aren't. See, this one only has those 2 up there. Same thing. And that one's not even close. So it's this one. Just realize that sometimes they don't continue the arc, but if we continued the arc, it would be the exact same thing as this.
Now this is probably going to tell us to do a construction. On this line segment below, use a compass and straight edge to construct equilateral triangle ABC. Leave all construction marks. Okay. Alright, that's a piece of cake. I'm going to do it, I don't think it's going to, yeah, it might, I'm going to do it, yeah, I'll do it going up the normal way. So you put your compass on the left point, and you open it up to it's on the right point. Okay? And then you make an arc. Just like that. Then you do the same thing from this side. Alright? And now you draw your equilateral triangle. Now I could have done it below the line so I didn't get in the way of the lettering, but on the Regents exam they won't make it that close. You'll have plenty of room. Okay? But that's how you do it. I could have done it down here too, but it doesn't matter. This is one of the easiest ones also. Same thing. Now, one of the things that I forgot to do, let's label this point C. Let's go over here and this says triangle ABC, so we need to label this C. Okay? So you don't want to lose a point on something like that, like I just would have. What's this say? Same thing. Okay, so I'm just going to turn it this way and do my triangle. And let's label that T, RST. Okay? So you can do it sideways, it doesn't matter. Now, let's see, we're getting into locus on the next ones. So I think I'm going to stop here for today. Yes, I am going to stop here for today. Alright, so actually I'm going to continue on with the locus ones also, and hopefully we're going to get through those. So town A and B are 16 miles apart. Okay, 16 miles apart. How many points are 10 miles from town A? So 10 would be like right about here. So let's say this distance is 10, and what you would have is that's a radius of a circle that's 10 miles from point A and 12 miles from town B. So I would go 12 miles this way. So let's say that this is 12 miles, and you have a circle around point B that's 12 miles. Right? All the points around point B are 12 miles away from B, and all of the points that are 10 miles around point A is this circle 10 miles around point A. So how many points are 10 miles from town A and 12 miles from town B? There's 2 points. It's where the two circles cross. A man wants to place a new bird bath in his yard so that it is 30 feet from a fence, F, and also 10 feet from a light pole, P. 30 feet from a fence, F is the fence, so 30 feet would be, this is 35 feet, so
this would be the first, that's 30 feet away, right? And this is also, so this is 30 feet, and this is 30 feet. So those two lines are 30 feet from fence F. And it also has to be 10 feet from light pole P. So if this is light pole P, we also have this circle with a radius of 10 feet. So you can see that there are 2 points that meet both of those criteria. Okay, so how many locations are possible for the bird bath? There's 2. Point M is located on AB. Sketch the locus of points that are 1 unit from AB. So let's say this is 1 unit. And it has to be on both sides, right? Because both of these lines would be the same distance from line AB. And the locus of points 2 units from point M. So that would be like that. Okay, so we would have 1, 2, 3, 4. It says, label with an X all points that satisfy both conditions. So there you go. Okay? And I can say, here, let's do this. Let's say this is 1 unit. I made that distance up myself, right? It just told me 1 unit, so I can make it any length I want. This one said 2 units, so it had to be about twice as big as the 1 unit one. So this is 2 units, the radius of circle M. 126. The length of AB is 3 inches. On the diagram below, sketch the points that are equidistant from AB. Alright, so that would be the perpendicular bisector of AB. Label with an X all points that set O. Oh, and 2 inches from A. Alright, so here's what you do. First of all, this thing wasn't 3 inches long, right? It was on the exam. So let's scribble it out. Let me actually take this one out of my binder here. And let's make AB 3 inches long like it's supposed to be. Alright, when this got photocopied, obviously it didn't come out right. So the length of AB is 3 inches. On the diagram below, sketch the points that are equidistant from A and B. That would be the perpendicular bisector of AB. So why don't we do it using our knowledge of constructions. Just nice and lightly make a thing like this. Okay. And now I'm going to go ahead and erase my construction lines because this doesn't say I need to keep my construction lines, and they're just going to look confusing if I keep them. Because I don't want you to confuse those with part of your locus. Alright? Okay, so there's the points that are equidistant from AB, and really I should have made this line dashed. So there, now it's dashed. Okay? And sketch the points that are 2 inches from A. Well, I just go 2 inches from A, and I do a circle with a radius of 2 inches. Okay? And there's 2 places where it crosses. Label with an X. You see how it says that? You lose a point if you don't use an X. And I used an X and a circle, and that's fine. Okay? So this line is the points equidistant from A and B, and this circle is all the points that are 2 inches from A. Now we're on 27. Almost done. Two lines, AB and CRD, are parallel and 10 inches apart. Sketch the locus of all points that are equidistant from A and B and C. Okay, so the ones that are equidistant would be, forget about what they're saying with 10 inches. Let's just go by what it is. So equidistant, if this is 3.5, it looks like, so I'm going to go 1 3/4. No, hell, this is 3.5. So I'm going to go 1.75, which is like, it doesn't have to be exact. Like right here. Same thing over here. 1.75. Okay, and I'll make a dash. Really, you should make a dash so that you don't confuse them with the other lines. So the locus should be dashed. Like that. So that's equidistant from the two lines, right? And 7 inches from point R. Okay. Well, if this whole thing is 10 inches, then we know this is 5 inches. So 7 inches would be like right about here. So we'll make a circle. I'm not even going to use the compass because it doesn't have to be perfect. Okay? As long as I have all my points that it's crossed, those two locuses are crossing. Alright, which would be, there's one here and there's one here. Okay? And that's fine. 128. Car A is 7 miles from car B. Sketch the points that are 4 miles from car A and sketch the points that are 4 miles from car B. Label with an X all points that satisfy both conditions. So if this is 7 miles, halfway would be 3.5. So I'm a little more than halfway. So I'm like right here from car A. So I'm going to just make okay, and then if I'm 4 miles from car B, it's a little more than halfway also. So let's say it's like right here. Okay, so make sure you put an X like it says. Alright? So those are the points that satisfy both conditions. And this distance right here is 7 miles. Right? Okay. In a coordinate plane, how many points are 5 units from the origin and 2 units from the x-axis? So if we have a coordinate plane, 5 units from the origin, so let's say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it's going to go here, here, 1, 2, 3, 4, 5, here, and here. Okay, and 2 units from the x-axis. This is the x-axis, so 2 units goes through 2 and -2. 1, 2, 3, 4. 4. Okay? How many points are both 4 units from the origin and 2 units from the line y equals 4? So we have to be a little bit more careful here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. 4 units from the origin. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 2 units from the line y equals 4. 1, 2, 1, 2, 3, 4. So this is the line y equals 4. So 2 units away from that would be here and here. So now I'm only going by where the two locusts cross. That means the circle and the other dotted line. So it's only here and here, so there's only two. Okay? Let's look at the next one. A city is planning to build a new park. The park must be equidistant from school A at 3, and school B at 3, -5. Okay. So equidistant from those 2 points is, these 2 points are 1, 2, 3, 4, 5, 6, 7, 8 apart, so I'm going to go 4. 1, 2, 3, 4, which would be right here, and I'm going to make a dotted line there. That's one of the requirements. Now the other requirement is the park also must be exactly 5 miles from the center of town. So here's the center. 1, 2, 3, 4, 5. It's got to cross there. 1, 2, 3, 4, 5 here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is A and B. So what you have is a circle that crosses that line. Each unit on the graph represents 1 mile. Yeah, that's what I did. On the set of axes below, sketch the compound loci and label with an X all possible locations for the new park. There's only 2 possible locations. That one and that one, where the dotted lines meet. Okay? 5 units from the origin. That's the first criteria. And 2 units from the line y = 3. Well, y = 3 is here. Notice how I made that line solid. And 2 units away from that line would be that line. And that line. Now remember, only go where the dotted lines meet. So here, here, and here. Not where the solid line crosses, okay? Only where the dotted lines meet. We're almost there. A couple more problems left. On the grid below, graph the points that are equidistant from both the x and y. So I got to draw an x and a y axis. Not that easy to see on this. So equidistant would be like that. Those intersecting lines are equidistant from the x and y axis, okay? And the points that are 5 units from the origin. Label with an X all points that satisfy both conditions. Okay? 4 points. On the set of axes below, graph the locus of points that are 4 units from the point 2, 1. So I'm going to go 4 above, 4 below, 4 to the right, and 4 to the left. And I'm going to make my locus of points equidistant from a point, which is a circle. Then what else? On the same set of axes, graph the locus of points that are 2 units from the line x equals 4. So this is the line x equals 4. 2 units away would be here, and I'm going to do this in dotted lines, right? And also here. So we have 1 point, 2 points, 3 points. See that? State the coordinates of all points that satisfy both conditions. So 2, 2, 5, 1, 2, 3, 4, 5, 6, 1, and 2, 1, 2, 2, negative 3. Now I have to go back and make sure none of the other questions they asked me to do that. I don't think they did. Most of them tell you to label with an X, but some of them, look, it says state, so now I have to write it. And if I didn't do that, I'd lose almost all the points for that problem. Let's see if there's any other ones. No, there are no other ones that do that, okay? So let's put this page away and take out the next page. Equidistant from the lines. Alright, so I gotta draw my axes a little. The y-axis is easy to see, the x-axis is not, so let me darken up the x-axis here. Okay, that's a little better. Equidistant from the lines y equals 6 and y equals 2. There's y equals 2, 3, 4, 5. Here's y equals 6. So we got y equals 2 and y equals 6. Now obviously the points equidistant from those two lines is the points directly in between them. Now I have to do this dashed. Alright. Now what else does it say? And also graph the locus of points 3 units from the y-axis. So that would be the line, 2 parallel lines that are 3 units from the y-axis. Okay. State the coordinates of all points that satisfy both conditions. So here's 1. Here's 2. Now it's only where the dotted lines cross. So that's it. Okay. So the points are negative 1, 2, 3, 1, 2, 3, 4. Negative 3, 4, and 1, 2, 3, 1, 2, 3, 4, and 3, 4. Okay? This time it told me to state them again. 36. I have the same problem with this graph. I have to darken this up. Okay, x and y. 4 units from the line x equals 3. So first I'm going to draw that line, x equals 3. 1, 2, 3. Hopefully by this point you're realizing you need to know what the lines x equals and y equals some number look like by heart, okay? So 4 units from the line x equals 3. So 4 to the right and 4 to the left. 1, 2, 3, 4. Make it dotted. 1, 2, 3, 4. It was right next to the y-axis. Okay. And 5 units from the point 0, 2. 0, 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we got that guy, and we got that guy. And that's it. Doesn't say to state, it just says to put an X there. Okay, and we got one more to do that involve locus. Those are the locus of points equidistant from the X and Y axis, right? Two intersecting lines that are exactly 45 degrees, or a slope of 1 and -1. On the same set of axes, graph the locus of points 3 units from the line x equals 0. X equals 0 is the y-axis. It's this line, right? Every point on this line has an x-coordinate of 0. So that's the line x equals 0. So 3 units away would be 3 to the right. And 3 to the left. And we just have to label with an X. Okay, that's it. So that is it for constructions and locus problems.